All right, guys, so today we are going over the review sheet. Most likely we're going to be going over it today and tomorrow just to make sure we get through everything we need to get through. So we're going to look at problems 1 through 5 first. Problems 1 through 5, evaluate each expression for x equals -2 and x equals 3. So 1 through 5, problems like this on the test, we'll have two answers. So we'll start off with -2. So if we look at number 1, we're going to evaluate 16 to the -2 plus 5. Now at this point here, we could type the whole thing in the calculator or simplify it first. So at this point here, we can grab either calculator and say 16 to the -2 plus 5, which is 4096. If we had simplified it, -2 plus 5 is 3. 16 to the third is still 4096. So that'd be our first part. That'd be half the answer. We evaluated it for when x is -2.
Pardon the interruption. I need sophomores with the last names that start with the letters A through L to go to the library at this time.
Now the other part, we're evaluating for when x is 3, so 16 to the 3 plus 5. 16 to the 3 plus 5. We get this number here, and that'd be our answer. 4,294,967,296. 4,294,967,296. No decimals, no rounding, we just take that whole number. Yep, it's a big number. Any questions on number 1? Any other one on 1 through 5 that we want to look at? So do we feel good with 1 through 5? Number 2, 7 times 2 to the x minus 3. Well, we're starting off with x is what? -2. So we'd say 7 times 2 to the -2 minus 3. 7 times 2 to the -2 minus 3. -5/4. Now we're going to do the same thing when x is 3. So 7 times 2 to the third minus 3. And again, we'll type it in to the calculator. 7 times 2 to the third minus 3 is -5/4. You can give it to me as -5/4, -1 1/4, or -1.25. As long as it's the same number, I don't care what form it's in. Any other questions on 1 through 5? So there will be 6 questions on part 1 that are over 1 through 5. You'll have 6 questions like this on the test. So that's kind of nice. We ready for the next set? Tell whether each function represents exponential growth or exponential decay. I didn't put any on the test. Not so much because I didn't want to put them there. We have a good number of the others on the test already. Yeah. (12 through 19), rewrite each equation in exponential form. There's going to be 8 of these on the test. Rewriting it from logarithmic to exponential. So to go from logarithmic to exponential, I do have it written on the sideboard. Log base b of x equals y if and only if b to the y is equal to x. We're going from logarithmic to exponential. So let's look at 12. Log base 9 of 6,561 is equal to 4. Well, our b in this case is 9. X is 6,561. And y is 4. And we want to rewrite it into b to the y is equal to x. Well, our base here is 9. And it's going to be 9 to the y, or 9 to the 4th, is equal to 6,561. Questions on this so far? What would 13 be? And that's it. Fifteen would be what? 15 to the first is equal to 15. Normally we don't write the first power, but again, we'll write it here because again, we want to show that this is exponential. 15 to the first is equal to 15. One of the few exceptions that we will write that first power. Questions on these first four? All right, let's look at 16 through 19. Natural log of x equals y if and only if e to the y is equal to x. Because again, the base for the natural log is understood to be e. So for 16, the base is e. Here it'd be to the what? Let's say you can place a y. So e to the 7 is equal to? All right. Natural log of 6 equals y would be what? E to the y equals 6. How about 19? E to the 9th is equal to x. That's it. Questions on going from exponential to logarithmic? There will be 8 of those on the first part of the test. We ready for the next set? 20 through 25, rewrite the equation in logarithmic form. So we're going from exponential now back to logarithms. So just the reverse, b to the y equals x if and only if log base b of x is equal to y. So we can look at number 3, log. So our base this time is what? 3 of 81 equals 4. So we're doing almost the exact same thing, but in reverse. Instead of us going from logarithmic to exponential, we're taking it back from exponential to logarithmic. For our next one, 1/5 to the 3rd is equal to 125. Log base 1/5. Questions on these here? Questions on how we're rewriting this? E to the y equals x if and only if the natural log of x is equal to y. So e to the 4th equals x. If we're rewriting this here, it's going to be the natural log of x equals 4. We don't have to write the base e with natural logs because it's understood. 24, we have a base e, so again, this is natural log of 27 is equal to 1. Questions on 20 through 25? There are going to be 8 of these problems on the test. You don't have to write those numbers down. It's just I'm letting you know how many are on that test part. Yeah. So again, that's part 1. Questions on this here? We understand how that works, and I'd make sure you do have those conversions just in case you need to look back at them. All right. Evaluate each of these logs around to 3 places. Now, there's different ways we can evaluate this, and all of them are calculus-based, or calculator-based. One, we can change it, use the change of base formula to type them in the yellow calculators. I have a feeling you'll want to use the graphing calculator, the 84 plus, because if we use this here, first thing we're going to hit is math. And then we're going to scroll up or down to log base and type it in. Now the first one that we're looking at is log base 5 of alpha y equals enter 1 over 125 is -3. Now we didn't have a decimal with this here, so we don't have to round it if we do have decimals. (27) log base 9 of 2,187. So in the graphing calculator, we'd hit what first? Math, and then scroll up or down to log base 9 of 2,187 is questions on that one there. 28, log base 10 of 0.00001. Base 10 is our common log, yes? So there's 2 ways we can do it. One is I can come over here and hit log of 0.12341. And it'll tell me that it is -5. Now if we wanted to, I could go math log base 10 of 0.12341, and it will tell me that it's -5. Questions on 26, 27, or 28? We feel good with those first 3 there. ln, natural log. Natural log, the base is understood to be e. There's no other base for e. So ln of 27, I can just use the ln button. Either calculator has it. ln of 27 is 3.295836866. 3.296. If it's funny on the rounding, you're not quite sure, give me the whole decimal. Round it to 3 places or give me the whole decimal, either one. Okay? Especially if you're not sure, we get 3.999, and you're not sure if it's going to round to all 3, just give me the whole thing. Because again, this here is just plugging in, not grading you on rounding. Because either give me 3 decimal places rounded or the whole thing, either one. And that's in the wrong spot. questions on 30 or 31? One of those that y'all want to see. Natural log of 4 to the 6. Natural log 4 to the 6. So we type it in just like we see it, 8.3177. 8.318. And that's it. Six, so these are on part 1. So you've been adding up so far, 6 goes 8, 16, and then 12 is 28 problems so far on part 1. Yes. And so far, even though there's actually 32 questions on part 1, 28 of them right there. So again, if we know, because really the only thing we're having to actually do ourselves for the most part is going from logarithmic to exponential, exponential to logarithmic. I would write that down, or at least have that. You know what? I'll keep it up there. But again, we know how to change it. That's not going to take that much time. The other 12 of them, evaluate. Plug it into the calculator, plug it into the calculator. Logarithms, plug it in, plug it in, plug it in. The last 4. 2 are expanding. 2 are condensing. When we expand logarithms, there's a specific order in which we expand it. Expand. Quotient. Property first. Log base b of m divided by n. Log base b of m minus log base b of n. Second one is our power. Not power, sorry, product. Also starts with b. Product. Log base b of m times n. Log base b of m plus log base b of n. And lastly is power. Log base b of m to the n quotient, product, power is how we do these here. I do also have it written on the sideboard. Quotient, product, power. And just as a reminder, it might be good to put in your notes, if something starts in the bottom of the fraction, its log should have a minus in front. If it's in the bottom of the fraction, its log should be negative or minus in front of it when we're done. So, if we look at, we'll start with 32, log of 6x cubed y squared. We have this whole term here. Quotient is first. Do we have anything being divided inside the logs? No. So, since there's no quotient, we move to product. We have 3 things being multiplied, yes? 2 or more things being multiplied inside the log can be rewritten as a sum. So we have log of 6 plus log of our second term being multiplied with this, which is x cubed, not x squared. And our third term is y squared. Then we will put the power in front of the log. Now, I'm not going to ask you to break the 6 into parts, because we could rewrite technically 6 as 2 times 3 and have log of 2 plus log, no. Leave it as log of 6. And the last one is the power. We pull the exponents to the front. So we do have log of 6 plus 3 log of x plus 2 log of y. Yep. I did. Okay. Questions on 32? We want to look at 33 or 34? 33. 33, log of 7x squared over y cubed z squared. So we have a rational expression. So our quotient is first. Our quotient says that we can rewrite this as log of the top minus log of the bottom. Log of the top minus log of the bottom. Now again, since we do have expressions on the bottom of the fraction, we're going to have to split those apart, but our log of y and log of z should both have a minus in front of them. They're both in the bottom of the fraction, they're going to need that minus. Let's look at, so we've done the quotient, we've done our division, yes? Product. Let's look at the first one, first expression first. Log of 7x squared. Well, this can be rewritten as log of 7 plus log of x squared minus. Now, our second expression does have a product in it. Now, log of y cubed z squared would be log of y cubed plus log of z squared, if we were just taking log of y cubed z squared. But we do have that negative, it's going to have to be applied through it. So really what we have is log of 7 plus log of x squared minus log of y cubed minus log of z squared. Both of those are negative. Since they're in the bottom of the fraction, they're both going to have to be negative. So that takes care of steps 1 and 2. Our third step is our powers. We're going to move both of those, all three of these powers to the front. Telling us we have log of 7 plus 2 log of x minus 3 log y minus 2 log z. Do you want to rewrite that 7? And that's it. Any questions on how we expanded any of this here? Questions on 34 or 35? Yeah, which one do we want to look at? 34. Now 34 is going to be the same as 32 and 33. But instead of having log, we're going to have natural log. It's going to work the exact same way. Since we have quotient first, two things being divided, we're going to take the natural log of the top minus the natural log of the bottom. Natural log of the top minus the natural log of the bottom. That's our quotient property. Natural log of 7x cubed, we have a product, so we can write it as the sum of logs with each term. So natural log of 7x cubed would be the natural log of 7 plus the natural log of x cubed minus natural log of 16y squared is also a product. 16. But again, that's in the bottom of the fraction. Both of those terms are in the bottom of the fraction, so when we get done, both of their logs have to be negative. So really looking at natural log of 7 plus natural log of x cubed minus the natural log of 16 minus the natural log of y squared. And lastly is our powers. Telling us we have the natural log of 7 plus 3 times the natural log of x minus the natural log of 16 minus 2 natural log of y. And that's as far as I want you to take it. Could we simplify it further? Yes. Because 16 is 2 to the 4th power. So, I mean, we could rewrote 16 is 2 to the 4th, really telling us that that term should have been minus 4 ln of 2, because some programs will take it that far. I'm not asking you to take it that far. It's expanded. Questions? Okay. And again, I wouldn't try to do it all at once. Do it one step at a time. I mean, you can, if you can see it and break it down, do it. But here, just so we don't get everything mixed up, it's sometimes easier just take it part by part. Questions on this here? We feel good with almost 1 through 35, except for the 6, I think, that aren't going to be on there. Yep. We're ready for the next part. Last 2 questions that are on part 1 are condensing. Condensing. The first step we're going to do is powers. Take the negatives with the power. 2, product. And the third step is to simplify. Simplify if possible. And what I mean by simplify if possible, if we have 3 to the 4th or 5 to the 2nd, and it simplifies, simplify it. So, we can look at 36. First step's powers. We're going to take each of the powers and move them back up into the exponent and take the negatives with it also. So 6 log of x is going to become log of x to the 6th. Plus, we take the 5, giving us log of y to the 5th. Now the next one is negative 4 log of 3 plus log of 3 to the negative 4th. If there's a negative in front of that number, just a negative in front of the log, we're taking the number and the negative with it. Questions on the first step? Product. If we have 2 or more things being added, 2 or more logs being added, we can rewrite it as a single log with what was in each side of a multiply, which would give us log, well, 3 to the negative 4th, x to the 6th, y to the 5th. I put the number first because normally we put our numbers and then our variables. Questions on how we got to this point here with steps 1 and 2. Step 3 is simplify, if possible. We can't leave a variable, or not a variable, but an exponent as a negative. But to get the exponent positive, we move it from the top of the fraction to the bottom. To make that 3 to the negative 4 have a positive exponent, we move it from the top of the fraction to the bottom. Okay? X to the 6th is as simplified as it gets. I mean, it's just x to the 6th. Y to the 5th, can't do anything with it. Can I simplify 3 to the 4th power? Yes. I can grab the calculator and say, what is 3 to the 4th? Which is 81. Which is telling me that this is log of x to the 6th, y to the 5th, over 81. That is condensed. Questions on 36? We feel good with 36. Yes? We can look at 37 next. It looks not as nice. But again, take it one step at a time. First step is powers. So that means the numbers in front of the logs are going to go back up to the exponents, which tells us that we have log base 4 of x to the 9/7 plus log base 4 of y to the 9. Questions about what we just did? We have two logs with the same base being added, so I can rewrite it as a single log with what's inside being multiplied. Questions on how we got to this here? Is either exponent negative? No. And we have x and y. We don't have numbers to a power, so there's no way to simplify it that way. This here is as simplified as it gets. We don't have to do anything else to it. Let's look at 38, 39. 38. 6 ln of x minus 4 ln of 2. Well, first step is our powers. So we move the powers back up. 6 ln of x is going to become the natural log of x to the 6. Negative 4 ln of 2. Well, we're going to take the negative with the 4, which is going to change it to plus ln of 2 to the negative 4th. Questions on this here? Okay, you sure? Or just processing? Okay. Because we want to take the negative with it, so we just have pluses, we just have product. It's going to make it a little bit easier to work with. ln of x to the 6 plus ln of 2 to the negative 4th. Since I have two things being added together, two logs being added together, we can rewrite it as a single log with what's inside being multiplied. So ln of 2 to the negative 4th, x to the 6, if you wrote it as x to the 6 times 2 to the negative 4th, they are the same thing. Because you can multiply any two things in any order, and it is the same. Multiplication works nicely that way. Do we have a negative exponent? Yeah, so we have to take that number with the negative exponent and move it from the top to the bottom, telling us that we have ln of x to the 6 over 2 to the 4th. If we have a number to a power, you're going to need to simplify it. So the top is going to stay x to the 6. Now 2 to the 4th, I believe, is 16. And that's it. We'll go and look at 39 last. Powers first. Powers first. So we're moving. So 2/3 ln of x is going to become ln of x to the 2/3 plus the second one, negative 5/3 ln of 27 We're going to take the negative 5/3 and move it back up into the exponent. Questions on the first step? We have two natural logs being added together, so we can rewrite it as a single log with what's inside being multiplied. We have a negative exponent. Yes. The 5/3 is 243. If we have a number to a fractional power, plug it in the calculator, check and see what you get. Here, 243 is a nice number. If we get a number that does not have a decimal, replace it. 243. If you got some non-repeating, non-terminating decimal, leave it in fractional power. But I believe all the ones on this here should, if we have a number to a power, should reduce nicely. And that's it for that one there. Questions on this here? I'm trying to remember what was the next set of problem solving.
May I have your attention? May I have your attention, please? Anyone who is planning on attending prom needs to go to Miss Bruckner's class at 11:37 today. Anyone who is planning on attending prom needs to go to Miss Bruckner's class at 11:37 today. Thank you.
Yeah, I mean, this is part one. All this here, that's the 32 questions for part one. Yeah, I thought about reducing it lower than 32, but I feel that, guys, this is doable in 32 minutes, or 50 minutes, these 32 problems. All right, so that is the first half of the test. We'll cover the second half tomorrow. Second half. Okay, I will have the video. If you're not here tomorrow, you're probably not here Thursday anyways. When you come back Friday, again, I will have the video posted. Watch that video for the test. Because again, the test is, part two is 20 questions. 6 of those 20 questions are change of base. Rewrite the log in terms of common log and natural log. And that's it. The other 14 are solving.